Hi everyone, today we'll be discussing how to reverse engineering Nate Silver's election forecast model. Uh, the talk will be two-part. First part, I will introduce the conceptual model of the poll-based election forecast model. The second part is we'll go into excruciating details about how Nate Silver did it. So first part is how to actually you model the poll process of poll-based election forecast. So the easiest thing to do is the last step. Let's say you want to predict who will take the White House this year. All you need to know is whether he or she gets more than 270 votes. In order to get that number, you need to know how many electoral college votes the candidate gets from each state. To get that number, you need to know what is the probability that candidate will carry that state. So at the end of the day, all you need to know is the probability distribution of candidate winning that state at the election day. Once you know that, all you need to do is do a simulation, and you will get the probability of candidate winning the White House. Now let's say you are standing at the election day, which is the problem we just described before. Now let's say you're standing one day before the election day. You are not quite there yet, so you need to predict what would happen in the next day. Though two things could mess you up if you just use the probability distribution of candidate winning that state at today rather than tomorrow. The one thing is that you could have some temporal dynamics. Let's say some crazy things happen. For example, Sandy actually happens quite close to the election day. This might change the odds of each candidate winning each state. Also, you could have some spatial dynamics, right? So let's say Chris Christie goes on national television and speak highly of President Obama, then I guess it helps to boost the numbers of Obama in Jersey. It could also help he gets a higher number in the neighborhood of. So you could have state one affect other states, and other states affect the state that you are interested in. So how we get to know this kind of prediction relationships, which is magnified as arrows here. Now this is quite hard. Basically what you do is you learn from the history and you try to make an educated guess about the future. The part you learn from the history is what we call propagation, and the part you make an educated guess about the future is what we call prediction. That is all well. The only problem being you actually didn't get to see the underlying latent state of the probability distribution. When we say latent, it means it is not directly observable, right? You can't go to Illinois and just ask, okay, what's the probability of Obama carrying these states? So you have to rely on some information, which is observable, to make an inference, or in another word, an educated guess about what is the underlying probability distribution. So, which brings us to the polls, which is the most frequent and probably most direct source of inference. Then you have a bit of a problem here because the polls are irregular. You can have polls that are taken at different times. Obviously, they should have different weights, right? The older polls should have lower weights, and the newer polls should have higher weights. Also, you can have the poll does not arrive regularly. It's not like every day you got a poll. Sometimes you get one poll, sometimes you get no poll, sometimes you get multiple polls. So how do you deal with that, right? So obviously, the inference made on multiple polls should be much more accurate than a day when you don't have any poll. Further, it's like we can ask a question: do we have other information that can help us to infer the underlying state? Let's say, I don't know, if you ever heard of a website called InTrade, which people can bet on the odds of each candidate winning the presidential election. If there's any inside information there, you probably could use InTrade to inform what is the probability distribution that presidential candidate will take the national election. So this is what we have at the last is the task 4, which is making inference. So which brings us to what did actually Nate Silver do. This presentation is based on the public information on blog 538, which unfortunately only details the methodology Nate Silver used in 2008. Okay, so remember our job is go from inference to propagation to prediction to simulation. So the first step will be inference. And that is the majority of Nate Silver's model will be dealing with, is how to make inference from the poll. He used a methodology he called poll rating. So the intuition is that you got a bunch of surveyor or poster that were conducting polls around the United States. Some polls are taken by a respectable survey house. Some polls are taken by Pondetry. Some polls are taken by God knows who. So of course their information content are different. And that's exactly what we want to measure so that we know which poll to give more weights in the final decision. Okay, so how did he do that? So first, you need to measure how wrong the poll can be. Just he did something to the poll result, which compared the poll to the final vote share, and he take a measure of how off that vote is. So now that is your left-hand side of the regression. Your right-hand side, you have a set of dummy for poster, a continuous variable for sample size, a set of dummies for election type, like which it's senator race, presidential race, or it's a house race, and which state are you in? Are you in Illinois, or in Arizona, or in California? Right? Then he also have medium field days. So what field days means is like during which time is the survey conducted in the field. So he takes the medium days and calculates the distance to the medium day to the election day. Let's say you take a survey on October 30th and the election is held on November the 5th, so the medium field days to election day is 5 days. And he squared that number, and all those stuff goes to the right hand side, which feeds into our RS model, has a fixed effect. So then you can predict, according to the model, you can predict what is the measurement error for a specific poster, controlling for the sample size, what the poll is about, and how long it is, how far away it is from the election. And we can repeat this process every year, so we can get a low score every year. So one thing Nate Silver finds here is that the sample size does not appear to have a large effect, which is quite surprising if you know something about survey statistics. So it suggests that actually the methodology each poll used are very different, and they just overwhelm the sample size. So what you actually can infer from that is some posters just suck in polling method. Okay, so now you get a low score for poster each year. Nate Silver noticed that if you look at the low score in different years, the same survey, the same poster tends to do better sometimes and tends to be worse at the other times. So basically, you have shrinkage to the reverting to the main problem. So he tries to capture this process in this step. So you get so basically you want to shrink the low score to some mean. So the problem being which mean do you revert to? So the server runs another set of model which has basically three inputs. First input is whether or not you are committed to some open survey standard. Some did, some don't. Whether or not you have an internet poll or you poll by phone, which is basically another measurement of a methodology, and whether or not you have a partisan bias. So the server didn't take any internal polls, but he views that some pollster may have certain particular political inclination. So which all these variables are measuring how good your methodology is. Because previously we know that methodology actually trumps the sample size in determining the accuracy of the poll. So which you get a bunch of group means which features a combination of this parameter. So the next question is how much do you want to shrink to that mean? So basically he take a shortcut in doing exponential decay. The intuition here is just the more poll you have in the sample, the more you will be reverted to the mean. Because I have a long run estimation, a better estimation of what your performance should be. But if you don't have that much polls in my sample, I don't want to really shrink you to the mean because I know very little about your performance. After the shrinkage, you just get the adjusted score, and you plus 2, you get the poll-induced error, which is strictly a positive number. So let's take a look at how each poster did in 2008. We didn't get the long-run PIE poll-induced error for 2012, but I guess things won't change that much. So if you look at the table, you will find that household name did not fare very well. Major network / planetary actually did quite bad for this polls. And I would say it's rightly so. If you know something about survey statistics, it will surprise you if they actually did a good job. So for more on survey methodology and polling, I strongly recommend you to listen to Don Rivers give a talk on Econ Talk, and he goes to much more details than I would possibly have time here. So after we get the poll-induced error, we still have a long way to go until we get to how they should be weighted in our final process. So the intuition of weighting here is twofold. First is we want to weigh better polls heavier than those poor polls, and we want to weigh much more on the recent polls than on the early polls. So in the first 4 steps, we are doing a methodology weighting. So what the server did here is he borrowed some intuition from the survey statistics literature, which is called effective sample size. So what it did is it compared 2 polls. One is a poll that you observed, another poll is a simple random sample. And for the requirement is for the 2 polls to have the exact same inference power. Let's say you have 1,000 observation in the poll that you are studying, how large the sample size it needs to be for the simple random sample. So if let's say you have one observation in the poll you are studying and you only need 500 observations in the simple random sample, that means your current poll actually sucks. But if you need 2,000 observations in the simple random sample, that means the poll that you are using right now is much more efficient. So what the server tried to do here is, let's say, okay, I define a medium average sample size poll and with average quality. And I transform that into effective sample size, which will be 283. And I compare any polls that I have in our database into effective sample size. If effective sample size is larger than 283, it will have a weight larger than 1. If it is smaller than 283, it will have a weight that is smaller than 1. After that, then we also want to do an exponential. We also want to weigh the pole according to their distance to the election, which can kind of is a measure of the relevance. So the recentness weighting is borrowed from this concept of exponential decay and half-life. So he choose the half-life means is that, let's say I take 30 days at my half-life. That means 30 days later, the weight on that pole will be decreased to 50%. And another 30 days, it will decrease another 50%, which will be 25. So, which will result in a 25% weighting, and so on and so forth. So, by this process, we get from poles to a final weighting on each pose, which enable us to aggregate over different poles. We can have another measurement of the latent state other than the pose. So we can actually regress, make a regression on the latent Boole shear state. And again, since the latent Boole shear cannot be observed, we can use some aggregation of the pose we used before. And this is basically De Silva's regression model, which he named 538. So he has a bunch of variables for political variable, religious identity, economic, ethnical identity, and demographic characteristics, which is what you would suspect that would affect a presidential election. So we will treat that as an individual poll, and the poll rating will be a weird weighted average of the poll rating that goes into regression. The cleverness of this method is that it provides an adaptive weighting of our regression result. Let's say if we can regress that in Ohio, which is a swing state, which is kind of hard to model because each candidate, the chance is 50-50. But you have a lot of poll there, right? Because it's swing state, everyone wants to do poll there. So actually, our regression will get a very low weight in that scenario. Let's say you take we do another regression on Illinois. Well, Illinois is kind of easy to model, right? It's hard for Obama not to carry in Illinois, which will be a shame. And I think everybody knows that there's not a lot of polls around, so you didn't actually get a lot of information on the Boole shear of Illinois, which then your model will get a high weight, and it's accurate, so it's a good news. So we are done with inference here, and we are going to move into propagation. Now, the propagation problem comes in where you have this trend line. You do this trend line adjustment. What De Silva has in mind is that there's a fluctuation of national sentiment, and that will have an impact on how each state behave. So what we first need to do is to make an inference on the national sentiment. What he actually did is he aggregated the polls into a state poster pair. For each pair, he basically aggregates polls. Let's say NBC did the 5 polls in Ohio. Then those 5 polls will be put together into that cell and we will come up with a weighted average polls, right? So for each day, at each state, each poster, we will get a bunch of cell estimation. Then we will just run. We can get that for each day, and we can just run regression and put a bunch of daily dummies, and it will get the coefficient loaded on each day, which will represent the national sentiment. So this is one of the toy example that Nate posted in his 2008 blog. You can see that estimation is quite noisy here. Of course, here he's using weekly. Later, he translates that into daily. So you can see that the estimation is quite noisy, so he needs to do a smooth, which he used basically a local regression. It's called ROIS. So after you do the smoothing, you get a daily trend. And then you subtract the daily trends from each pose, and you get a detrended pose for each state. So later, Nate Silver realized that that is probably not the best and brightest idea, because the trend line tends to be state specific. So later, he actually come up with some method to calculate the sensitivity of each state with respect to the national sentiment. The way he did that is, after we get the daily sentiment nationally, he also do a similar calculation about how each state fluctuates from one day to another, and just you calculate the correlation coefficient on the two time series, and you get a state-specific trend sensitivity, which will be, as you would expect, incredibly noisy. So he further do a regression on the state-specific trend sensitivity on a bunch of demographic variables, and obtain a smoothed state-specific trend loading. So rather than subtract the national sentiment from each state uniformly, now you subtract the national sentiment times the state-specific trend loading from each pose. Let's say, for example, Obama had 2 points lead in the national sentiment fluctuation. Let's say he did very well in the third debate. Then let's say Illinois is very, very strong, a very strong Obama state, so it is very sensitive to the good news coming from the Obama campaign. So let's say his coefficient is 1.5. That means in order to detrend from the national sentiment, we need to subtract 2 times 1.5, which is 3 points, from the polls, and Obama has in Illinois. So let's say the field margin is 10% between Obama and Romney. After detrending it, it will be only 7 points. So it will model the underlying state better, because we know that all those fuzz will possibly fade away in the final election day. So that is how we actually learn from the history about how the polls. It's actually how we learn from history that what the latent state is. So that is how we do propagation, which is trendline adjustment. Then we'll leave with now next task is prediction, which Nate dubbed as projection. So you're not at the election day yet. You want to forecast how the things will go to there. So you want to do a similar process as what we did just in the trend line adjustment. We want to first incorporate the idea that we have mean reverting. The trading candidates tends to be catching up as we run into the poll. So here, basically, you calculate what is a national historically. Let's say, look at the past 20 presidential election. Historically, what is the national margin of lead at the third day, and how they fade away into the final election day. So you're using ROS model to get this coefficient. So you will know, let's say if the coefficient is 0.05, that means if Obama has 10 points lead right now, historically at the election day it will only be a 5 points lead. So that's on the national level. so we will be borrowing the state-specific trend loading from the previous calculation, and we will be basically as the same way we did with the trendline adjustment. We will basically do a state-specific shrinkage to the mean. The smooth state coefficient trend loading has similar machinery as we did before, but actually when Silver did it, he had different weighting on the pole. So they are not exactly the same, which reflects the difference between propagation and prediction. So you will get mean revert. So you get basically a predicted lead of each candidacy in each state. But that is with respect to the decided voter. What about the undecided voter? So what they did here is just he evenly split them between the two candidates. And if you aggregate them up, then you get the predicted state margin at election day, which is what is the likelihood that, let's say, Obama and Romney will carry that state. In 2012 version, he also has a likely voter adjustment, but here we are just don't know enough what he did here. So last step is we want to do a simulation. We get point estimation from the previous hodgepodge, but to do a simulation, we also need the covariance matrix. So we will go into a little bit of statistical details here. So if they are ID, then we can assume that each state is just a binary distribution, which will be easy to sample from. But if they're not ID, then it gets really tricky, and we need to get a covariance matrix for all the states. Silver actually make a more generous model that the covariance matrix is not ID, but the documentation is missing in this part, so I can't actually recover what he did with respect to the covariance matrix. So someone might ask, like, if you already know the probability of each candidate taking each state, why don't you just take expectation? The problem here is that the assignment of the electoral college vote is not linear. If you win 55%, it's not like you're going to get 55% of the electoral college vote. You probably will get all of them if you carry that state. Some states might actually have this proportional assignment, but some states don't. So the only way that you can actually make a reliable inference is just to simulate a gazillion situation and see from the gazillion situation how many times Obama actually wins the election. And that is why then the solver can make a probability statement before the election that President Obama has 84% of chance of winning the election seat. Although from the national average polls, the margin could be rather thin, but if you go down into each state and you do and get rid of the noise, it is actually pretty obvious that President Obama has a pretty good odds of winning. So some final words. When I start to reverse engineer Nate Silver's model, I was expected to see a very sophisticated econometrics model that can make a good inference, which is actually not the case. The model specification is not optimal, at least for the 2008 version. And he failed to use some more advanced machinery, which some have been known in the field for 50 years. If we adopt our first graphical presentation of the model, this kind of problem is known as common filter, and this has been around since you guys shoot a rocket to the moon. So yeah, we do have some rocket science that's just later on not being used. But what surprised me is that Nate Silver is an incredibly good engineer. So he combines engineering ingenuity and political insight to build up a very complicated machinery, use simple if not dumb models. And each models boost each other. The different models boost each other's performance quite well. So, and how he did that is, I think, is because he knows exactly what is the problem to address. He has some very good political insight into the election business. Which brings me to another question: is why nobody else has done this? I was quite surprised that this is not an incredible hard problem, and why just Decode will be the first and the best. Uh, One thing that I can come up with that this just needs a interdisciplinary team. You need someone who knows political science, someone knows econometrics or machine learning, someone knows service statistics, and someone is willing to spend all the time to collecting those poll data. Well, it just happened that Decode has all of them, and although he is not excelled at each element, he is probably the first one who is competent enough in all this area to cover this topic. The second problem could be there's just no incentive, right? So if you're a professor, you do all this machinery, it's interesting and fascinating, but all that aside, you won't ever publish a paper on this. So they're not interested. And I don't think if nobody's buying those data from you, you can't actually sell your product. So you probably won't have a commercial market either. So I guess Decode just not only had the competence, but he also had this passion for data-driven analysis, which just drives him to provide this public good to everyone. Or the last alternate hypothesis I would come up with is that actually each campaign had their own in-house prediction machinery, but they're just very secretive about it. They actually have some model. They must be very good, and if you have an ace up your sleeve, you just don't want to show it every time. But from this time on, I think this is going to be a competitive arm race really soon. Everybody will jump on the wagon, and just like high frequency finance, the algorithm will just get much better, and in return, the poll data will actually get much better because a good algorithm requires good poll. So yeah, I think this is a fascinating area, and it's a fascinating showcase of how far some simple econometrics can go in terms of understanding and changing the real world. Thank you for watching.